Hello! Today we're going to make place value clear, useful, and much easier to see. A number is not just a row of digits. Every digit has a position, and that position gives the digit its value. That is the key idea. Do not trust a digit until you know where it is standing. The digit 5 can mean 5 units, it can mean 50, it can mean 500, it can mean 5,000, it can mean 5 tenths, it can mean 5 hundredths, or it can mean 5 thousandths. Same digit, different place, different value. So when you see a number, do not ask only, what digit is it? Ask, where is it? Let's start with the number, 384. On the place value mat, we have 3 columns, hundreds, tens, units. The digit 3 is in the hundreds place, so it is worth 300. The digit 8 is in the tens place, so it is worth 80. The digit 4 is in the units place, so it is worth 4. That means 384 is the same as 300 plus 80 plus 4. That is expanded form. Expanded form opens the number up and shows the value of each digit. Now let's build it with place value blocks. A unit cube is worth 1. A 10 rod is worth 10. A 100 flat is worth 100. A 1000 cube is worth 1000. To build 384, 300 flats move into the hundreds column. 8 10 rods move into the tens column. 4 unit cubes move into the units column. Now read the build. 3 hundreds, 8 tens, 4 units. That is 384. Notice something important. The blocks are not just placed anywhere. They are organized by value. Hundreds with hundreds, tens with tens, units with units. If a 10 rod slides into the units column, it does not become worth 1. It is still worth 10. The place value mat helps us see where each value belongs. Let's try another one. 527. The 5 is in the hundreds place, so the 5 is worth 500. The 2 is in the tens place, so the 2 is worth 20. The 7 is in the units place, so the 7 is worth 7. Now build it. 500 flats, 2 10 rods, 7 unit cubes. Read it back. 500 plus 20 plus 7 equals 527. Now, a quick check. In 692, what is the value of the 9? Give it a moment. The 9 is in the tens place, so it is worth 90. Not 9. 90. What is the value of the 6? The 6 is in the hundreds place, so it is worth 600. What is the value of the 2? The 2 is in the units place, so it is worth 2. So 692 is 600 plus 90 plus 2. Now let's look at a number with a 0. 4,305. The 4 is in the thousands place, so it is worth 4,000. The 3 is in the hundreds place, so it is worth 300. The 0 is in the tens place, so there are no tens. The 5 is in the units place, so it is worth 5. Now build it. 4,000 cubes, 300 flats, no 10 rods, 5 unit cubes. The tens column is empty, but it must stay there. That 0 is a placeholder. It holds the tens place open, so the other digits stay in the correct positions. Without the 0, 4,305 could look like 435. That is not a small change. In 435, the 4 is worth 400. In 4,305, the 4 is worth 4,000. So 0 may look quiet, but remove it and the whole number changes. Let's use another example with a 0. 2,047. The 2 is in the thousands place, so it is worth 2,000. The 0 is in the hundreds place, so there are no hundreds. The 4 is in the tens place, so it is worth 40. The 7 is in the units place, so it is worth 7. Build it. 2,000 cubes, no 100 flats, 4 10 rods, 7 unit cubes. The hundreds column is empty, but the 0 keeps that space open. Zeros are part of the structure. Now let's step back and look at the pattern. As we move one place to the left, the value becomes 10 times greater. A 10 rod is 10 times the value of a unit cube. A 100 flat is 10 times the value of a 10 rod. 1,000 cube is 10 times the value of 100 flat. Then we keep going. 10,000, 100,000, 1 million. Each place is 10 times the value of the place to its right. Now look at 28,461. The 2 is in the 10,000 place, so it is worth 20,000. The 8 is in the thousands place, so it is worth 8,000. The 4 is in the hundreds place, so it is worth 400. The 6 is in the tens place, so it is worth 60. The 1 is in the units place, so it is worth 1. So the number is 20,000 plus 8,000 plus 400 plus 60 plus 1. Now build it. 2 10,000 blocks, 8,000 cubes, 400 flats, 6 10 rods, 1 unit cube. The number looks longer, but the method has not changed. Digit, place, value, block. Now let's go bigger. 7,352,918. For large numbers, commas help us read in groups. Start from the right. The first group is the units group, 918. The next group is the thousands group, 352,000. The next group is the millions group, 7 million. So we read the whole number as 7,352,918. Now find the values. The 7 is worth 7 million. The 3 is worth 300,000. The 5 is worth 50,000. The 2 is worth 2,000. The 9 is worth 900. The 1 is worth 10. The 8 is worth 8. Now build it from left to right. 7 million blocks, 300,000 blocks, 5 10,000 blocks, 2,000 cubes, 900 flats, 1 10 rod, 8 unit cubes. Now let's build a number from blocks. Suppose the map shows 3,000 cubes, 600 flats, 2 10 rods, and 9 unit cubes. 3,000s is 3,000. 600s is 600. 2 10s is 20. 9 units is 9. Put them together. 3,000 plus 600 plus 20 plus 9 makes 3,629. Next, 5 10,000 blocks, no 1,000 cubes. 700 flats, 4 10 rods. 2 unit cubes, that gives 50,000 plus 0 thousands plus 700 plus 40 plus 2. The number is 50,742. The 0 in the thousands place matters. Without it, the number could be read as 5,742. That would lose 45,000. A missing 0 can cause a very expensive mistake. Now I give the number. You choose the blocks. 81,306. The 8 is in the 10,000 place, so use 8 10,000 blocks. The 1 is in the thousands place, so use 1,000 cube. The 3 is in the hundreds place, so use 300 flats. The 0 is in the tens place, so use no 10 rods. The 6 is in the units place, so use 6 unit cubes. Read it back, 81,306. Now let's build one more large number. 2,631,405. Start from the left, the 2 is in the millions place, so we need 2 million blocks. The 6 is in the 100,000 place, so we need 600,000 blocks. The 3 is in the 10,000 place, so we need 3 10,000 blocks. The 1 is in the thousands place, so we need 1,000 cube. The 4 is in the hundreds place, so we need 400 flats. The 0 is in the tens place, so we need no 10 rods. The 5 is in the units place, so we need 5 unit cubes. Now read the value. 2 million plus 600,000 plus 30,000 plus 1,000 plus 400 plus 5. That makes 2,631,405. The method is steady. Line up the places, read the digit, say its value, choose the block. Now we cross the decimal point. The decimal point separates whole values from parts of one whole. To the left of the decimal point we have whole places, units, tens, hundreds, thousands, and beyond. To the right of the decimal point we have parts of one whole. Tenths, hundredths, thousandths. We are only going as far as thousandths. Imagine one whole block. If it is split into 10 equal strips, each strip is 1/10. If it is split into 100 equal squares, each square is 1/100th. If it is split into 1000 tiny pieces, each piece is 1/1000th. The decimal point is the anchor. Immediately to its left is the units place. Immediately to its right is the tenths place, then hundredths, then thousandths. Look at 3.482. This can also be read as 3 and 482 thousandths. The 3 is in the units place, so it is worth 3. The 4 is in the tenths place, so it is worth 4/10. The 8 is in the hundredths place, so it is worth 8/100ths. The 2 is in the thousandths place, so it is worth 2/1000ths. Now build it. 3 whole blocks, 4/10 strips, 800 squares, 2,000th pieces. Read it as values. 3 plus 4/10ths plus 800ths plus 2,000ths. That is 3.482. Now build 2.36. The 2 is in the units place, so use 2 whole blocks. The 3 is in the tenths place, so use 3/10 strips. The 6 is in the hundredths place, so use 600th squares. There is no thousandths digit, so no thousandth pieces are needed. 2.36 is 2 wholes, 3/10ths and 600ths. Now look at 5.079. The 5 is in the units place, so use 5 whole blocks. The 0 is in the tenths place, so there are no tenth strips. The 7 is in the hundredths place, so use 700th squares. The 9 is in the thousandths place, so use 9,000th pieces. 5.079 is not the same as 5.79. In 5.079, the 7 is worth 7/100ths. In 5.79, the 7 is worth 7/10ths. 7/10ths is much larger than 7/100ths. That 0 changes the place of the digits after it. 5.70 has the same value as 5.7. The final 0 adds no extra value, but 5.07 is not the same as 5.7. In 5.07, the 7 is in the hundredths place. In 5.7, the 7 is in the tenths place. Same digit, different place, different value. Let's compare 2 decimals, 4.7 and 4.07. Start with the whole number part. Both numbers have 4 units, so they are tied so far. Now compare the tenths place. 4.7 has 7/10ths. 4.07 has 0/10ths. So 4.7 is greater. You can also write 4.7 as 4.70. That does not change its value. Now compare 4.70 with 4.07. 4.70 has 70/100ths. 4.07 has 7/100ths. 70/100ths is greater than 7/100ths. The blocks show it clearly. 7/10 strips cover much more of the whole than 7/100th squares. Now, build 14.625, use 110 rod, use 4 whole blocks, use 6/10 strips, use 200th squares, use 5,000th pieces. Now, build 0.508, there are no whole blocks. There are 5/10 strips, there are no 100th squares. There are 8,000th pieces. 0.508 is not the same as 0.58. In 0.508, the 8 is worth 8,000ths. In 0.58, the 8 is worth 800ths. Now let's finish with a challenge round. I will describe the blocks. You say the number. 4,000 cubes, 200 flats, 9 10 rods, 6 unit cubes. That is 4,000 plus 200 plus 90 plus 6. The number is 4,296. Next, 700,000 blocks, 3 10,000 blocks, no 1,000 cubes, 800 flats, 1 10 rod, 5 unit cubes, that is 730,815. Next, 5 whole blocks, 6/10 strips, no hundredth squares, 3,000th pieces. That is 5.603. Now I give the number. You choose the blocks. 608,240. Use 600,000 blocks, no 10,000 blocks, 8,000 cubes. 200 flats, 410 rods, no unit cubes. Now build 12.304. Use 110 rod, 2 whole blocks, 3/10 strips, no hundredth squares, 4,000th pieces, that is 12.304, not 12.34. The 0 keeps the 4 in the thousandths place. Final value check. In 5,086,201, the 8 is worth 80,000. The 6 is worth 6,000. In 7.039, the 3 is worth 300ths. The 9 is worth 9,000ths. Let's lock in the lesson. Place value tells us what a digit is worth because of where it is positioned. To the left of the decimal point, each place is 10 times greater than the place to its right. Units, tens, hundreds, thousands, 10,000s, 100,000s, millions. To the right of the decimal point, each place is 10 times smaller. Tenths, hundredths, thousandths. Place value blocks make the values visible. Unit cubes show single units. 10 rods show tens. 100 flats show hundreds. 1,000 cubes show thousands. Labeled blocks show 10,000s, 100,000s, and millions. 10th strips show tenths. 100th squares show hundredths. 1,000th pieces show thousandths. When you see a number, ask 3 questions. What digit do I see? What place is it in? What value does that give it? Then choose the matching block. A 4 in the hundreds place needs 400 flats. A 4 in the thousandths place needs 4,000th pieces. Same digit, different place, different value. Line up the places. Read carefully. Build carefully. Let each digit show exactly what it is worth.